Let's say you want to record some cockpit videos. You mount some cameras, connect a voice recorder, manage to capture sound and video during the flight, but then you have to align all those recordings in a video editor. It turns out to be quite a hassle. Is there any way to make this easier? I'm Greg from Inside Machines Laboratory, and in this video I will show you a simple device that you can build yourself that will make synchronizing sound and video easier and much quicker. Now, I will not go over recording audio in the cockpit, as there are many tutorials on YouTube that deal with this topic. For example, check out this video from Stefan. Stefan has a background in media production and runs a very successful aviation channel, so you can't really go wrong following his advice. I'll put a link in the description below. So I'll assume here that you know how to record audio and video in the cockpit, but you struggle with aligning them later in post. The standard solution is clapping at the start of every clip. Clapping makes a distinct sound accompanied by an obvious visual cue, something that you can later use during editing to synchronize video with audio. Unfortunately, when recording cockpit videos, this simple solution has some downsides. First of all, you need both hands. This can be a problem in choppy air when you need to keep at least one hand on the controls. Second, clapping sound may not get recorded. Microphones in aircraft headsets are designed to capture mainly human voice. The clapping sound will often trigger the microphone, but it's not guaranteed, and you may end up clapping like crazy while the aircraft is flying itself. The third problem is that clapping is relatively difficult to detect automatically. If you try to write a script that splits the audio track into scenes based on clapping, you will probably find that this task is not trivial. That's partly because the audio track recorded from headset microphone is likely to contain various types of noise, including some cracking sounds from the radio. Such sounds can be similar to clapping and hence may fool the algorithm that is supposed to split the audio track. The solution would be to build a small device that sends an easily distinguishable tone directly to the voice recorder. Such a tone should be a square wave, as this is the easiest signal to detect in a simple program, and since it is recorded directly, there is no risk of any noise interfering with it. You will also need a short script that will analyze the audio track and split it every time it detects the tone. We've built such a device and have written such a script. We called it CAVS, which stands for Kind of Automatic Audio to Video Synchronizer. It's not fully automatic because there is one thing you need to do manually, but more on that later. There are at least 3 advantages of such an approach. First of all, one-hand operation. Assuming that you keep the device in an accessible place, you can simply raise it to the camera view and press the button, no clapping. Second, the tone on the audio track is clean even if the microphone is picking up some background noise. That's because the signal is recorded directly to the voice recorder and not via the mic. And last but not least, such a tone is easy to detect automatically with a short script. So let's now go to DaVinci Resolve and see how this gizmo helps with editing. I have a sample project here with just 2 short video clips and a single audio file. This is the raw audio track from the voice recorder. It contains the tones generated by CAVS, but wasn't split into multiple clips using our script. Nevertheless, when I scrub through the recording, I can find the tones quite easily. Here's one. Let's find another. Maybe here? No, that's just some talking. Here? No. 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 Wait, there was some high-pitched tone. Let's rewind. That's definitely the tone. Finding a clapping sound like that would be much more difficult, especially if it was hidden inside some radio conversation. Let's set the playhead at the start of the first tone. Now let's bring in the first clip. We have to find the first frame when CAVS is activated. Should be somewhere here. That's the spot. The red flashing LEDs indicate that the tone is being generated. Yeah, that's good. Let's fast forward a bit to see how good is the alignment. Engine start. That's good. Let's find some talking. Here. Yeah, that's correct. Let's find the second tone. Here. Zoom in, locate the first frame. Bring in the second clip. Find the first video frame with the LEDs turned on. Somewhere here. This should be fine. Yeah, that works. There's no talking in this clip, only some background chatter, but the audio and video seems to be aligned properly. Now I'll show you how to run the script and how the whole editing process becomes even easier when the audio recording is automatically cut into parts that start with tone. The script is a command line tool, so I've opened PowerShell. If you're working on Linux or a Mac, you can use whatever console you have. I'm in the video project directory. I'll list the contents. This is the script file and the audio file. The script is written in Python, so let's run the Python interpreter and give it the script and the audio file as input. We get some basic information about the audio file, sampling rate and length in seconds. Now the script is looking for tones. It found one at second 52, another one at 12:16 almost, and a third one. So there are 3 tones. We have only 2 video clips, so we'll use only the first 2. Let's see the list of files again. And we have some new files. These are the audio tracks that were extracted from the original audio file. All of them start with a tone and last till the next tone. I'll go back to DaVinci Resolve and try to use them. I have all my clips here, including the new audio files. I'll add the original audio track once more to the timeline, just to show you that the files created by the script are simply parts of the same recording. Here's the first tone, and that's the first clip produced by the Python script. You can see by looking at the waveform that this is the same recording. Let's place the second clip just after the first. And the third one. See, it's the same, only split into pieces, and each piece starts with the tone. Okay, now we can remove the original audio track and try to align the video clips. Here's the first one. Let's find the first frame with the LEDs on. Here. Let's see the engine start sequence. Okay, and the talking part? Also good. Now for the second clip. We don't have to scrap the audio track to find the second tone because we know that the next audio clip starts with the tone. So we know where to put the video clip. We need to do the aligning manually, and that's the reason why Curves is only kind of automatic and not fully automatic, but this still makes editing easier and faster. Here's the frame with flashing LEDs, and now the video is aligned with audio. Now I'm sure you are dying to see the device in more detail, so let's move to the cutting board. This is a regular digital voice recorder. It has 2 audio jacks at the top. One of them is for a microphone and the other for a speaker or a headset. Now let's say that this is a microphone cable. We can connect it to the jack and record audio, but if we want to use our little tone generator, we need some way to connect a second device. And this is where this little guy comes in. This is an audio splitter. It allows us to connect 2 devices to a single jack. We connect the microphone via the splitter and use the second socket to connect Curves. The Curves device is very simple. As you can probably tell, we've used an effervescent tube as a case and put all the electronics inside. The red button at the top is what activates the device. At the bottom, we've placed an audio jack. We can use this jack to connect the device through our splitter like so. Now that Curves is connected to the voice recorder, we can start recording. The audio will be recorded from the microphone, but once we press the red button on Curves, The signal from the microphone will be mixed with a relatively loud tone. This is why even if the audio signal from the microphone contains some noise or chatter, the tone will break through. The CAVS device is built around a cheap 8-bit microcontroller, shown here in the center. The device is powered by a 3-volt coin battery, has 2 red LEDs, one 2 kΩ resistor, and a monostable switch at the top, that's the red button. There's also an audio jack at the bottom, and on the diagram you can see which parts of the plug are connected to which parts of the circuit. The microcontroller can be programmed with Arduino, and the program is probably the shortest functional program possible, only 2 lines. You can find all the resources about this device, including the diagram and the source code, on our GitHub page. I'll leave a link below. And that's it. I hope you found this video useful and maybe even inspiring. Let us know in the comments section if you consider building such a device yourselves, or maybe you have a better way of aligning your video and audio recordings. Let us know. But for now, thanks for watching. Bye!